Okay, folks, here, you are now aware of this, right? What is it called? This thing here. Black shows option pricing model, correct?
Yes.
Okay. So you can see here that this is a call option. And when ND1 and ND2 are equal to 1, it is nothing but the formula value, S sub 0 minus present value of X. Okay, and you know how to solve this problem by solving D1 and D2, finding out ND1 and ND2 from the table, and then put in, and then you get a C. So how many variables in here?
5.
Very good. So in this case, what is the unknown?
C.
Very good. Very good. C is the unknown. Rest of them are known, right? S sub 0 is known, X is known, R is known, T is known, right? All of them are known. Now, implied volatility is kind of a very clever method. They say that a call option value will depend on volatility. And volatility measure can come with many pitfalls. So as long as your known variables have pitfalls, so will your call option price. So the clever method is this, that out of these 5 variables, they thought C is unknown, therefore solve for C. They would like to now say, I will assume whatever is in the market has a price. I will put that price in here. I'll put the price in here and then solve for sigma. Do you see the twist in here? Black-Scholes originally wanted to solve for C based on 4 other variables, which are S sub 0, X, R sub C, T. But now we say that instead of solving for C, we'll assume that these call option or these processes that you see is generated by the market. So they put the market C, whatever option price you see in the market, right in here, and then solve for sigma. And they called it implied volatility because it is implied by the price that is obtained in the market. Okay, that's implied volatility. And I have to start as a starter, we introduced to you there. So then, of course, historical volatility can be calculated just looking at all the numbers. You know how to calculate a standard deviation. So it can be calculated, but those are historical numbers. History does not represent mystery. That is the beauty of finance. If you say the call price today is $13.24, do you know what would be the call price tomorrow?
No.
You don't, right?
Yeah.
All the information as of now is included.
All right, if you're going for buying, you got all the way to
13.24. Do you see what I'm saying? That is finance is always forward looking.
Mm-hmm.
So you cannot use the history to talk about mystery. Do you understand my statement here? You cannot use the historical volatility to talk about volatility that will be present in future.
Yeah.
So this is the path. Given these challenges, we look at the implied volatility, and I bring this back again. And in there, I explain here Can you read my handwriting here?
I can make something of it.
Yeah, good. Thank you. And so instead of solving for C, solve for sigma. This is one equation with 5 variables. Here C is treated as unknown. For implied volatility, treat sigma as unknown. You put market price of call option as C on the left-hand side, then solve for sigma implied by the market price of C. Is this clear to you?
Kind of.
So
yeah.
That means all the things that I said before, I put it in writing. That this is, you put market price in here, solve for sigma, and that sigma is implied by the market price. That's why it's called implied volatility.
Oh.
Then in another slide, I said, say implied volatility comes out as 55%. You expect the market volatility to be 60%. How do you expect something? You generated EST. You will be generated EST again. How do you generate EST? Or in this case, expected volatility, how do you get it? Do you say, I felt like it?
What was that?
Do you say that, well, I felt like it? I feel that expected volatility will be this one. Or do you say, I have to do the due diligence? Which one is the thing to do?
Due diligence.
Yeah, due diligence. Your EST is done through due diligence. So you see that, well, given the scenario that is prevailing now, and look at the numbers and then say that, well, I believe that expected volatility will be between this and that, range bound, between this and that, maybe 60 and 62. Okay, so now you have two numbers. Implied number is 55 and expected number is 60%. Now this is the decision criteria here. If your expected volatility is greater than the implied volatility, you buy the call. If your expected volatility is less than implied volatility, you sell the call. Can somebody tell me why that is the case?
Because if you're expecting the volatility to increase and decrease, it will give you a better chance of the option reaching where you desire.
Yeah, Kevin, I mean, implied volatility comes from the model, right? It is implied by the market price of call, right? So that implied volatility is less than expected volatility, that you expect the volatility
to be less.
Yeah, and then volatility is value augmenting or value decreasing?
Value increasing.
Value increasing. So if you believe the expected volatility is greater than what is implied by
then
the
you create
current
more value.
market, yeah, it will be more value. Do you see that, everybody? Do you see that? This is the criteria. Because volatility is value increasing, and this implied volatility is coming from the current market price. So the current market price must be up in value because they say expected volatility should be higher than implied. And can somebody explain it to me, this one?
Do you want me to go, or do you want someone else to go? Professor?
Yeah.
Would you like me to go, or
Yeah.
would you...
Anybody, and Kevin, you start, and somebody can support you or correct you.
Basically, it would just be the opposite of what we said in the first one, where it increase the value if the expected volatility is less than the implied volatility. It would decrease the value of the option.
Yeah. Anyone else would like to chime in? So prepare for a question on implied volatility and explain it to me. Okay.
If
Is
that's
there,
on a
yeah.
quiz, Professor, do you want me to go more in depth on that, or is that a nice
This
little
is
answer?
good enough in these 2 slides that I have.
Okay.
If you can give these 2 slides, it is good enough.
Okay.
Yeah. I did not want to bombard you with many, many different slides.
Yeah.
Right. And then, how do you get, now that you know, you figure out the call prices, how do you get the put price? You say, I don't worry at all because this is the way I'll do it. And what is this equation? Put call parity. By the way, who is doing the chapter 5 solutions on Thursday? Is it David?
Yes, that would be us.
Okay.
Group 4.
Okay, thank you. What's your asset ETF, David?
We're doing LQD.
LQD. Oh, good. All right. So you use put call parity to find out the put. Okay. Now, even though option we use this as a risk management tool, okay, we can show you that this can be applied as dynamic hedging, not just simple static hedging, dynamic hedging. Okay, let me explain it to you. Let's say you buy a stock. What are you afraid of when you buy a stock? Let's say you have an ETF. What are you afraid of?
The price going down.
Dropping in price.
Yeah, dropping in price. Yeah, price going down. Okay. Now, in order to make sure that it doesn't hurt you, what can you do with option? You put a portfolio, and that is the concept of student managed hedge fund. That you manage the risk. How do you manage the risk? Let's say there are 2 kinds. The first I will explain what is known as delta hedging. And then second is that I would also mention what is known as, very popularly known as covered call. So people who buy stock and they see this is a boring stock. It's not going anywhere. It's a sideways movement. Okay. So what they can say that, well, I bought the stock at 50 and wanted to sell it at 62. My profit exit point is 62. What can I do? They say, sell a call. Sell a call with a strike of 62. So that people who buy the call with a strike of 62 and the stock starts to go up, and at that point, when it crosses 62, do they exercise that call option or not exercise the call option?
They exercise it.
They exercise it. When they exercise it, what happens to you who was holding the stock and then sold the call? That you delivered the stock to that person, correct?
Mm-hmm.
Did you lose? You wanted to sell it at 62.
No, you won.
You won. But there is another thing that has happened though. You sold the call and you also earned the money in the process. Okay? So you see there is a symbiotic relationship between a stock and writing a call. And this is very popularly known as covered call. The call is covered by the stock in hand. And now we look at the delta. Delta is, as you know, you already did that very early on when we were doing the features, that it is, if delta is 0.5, then what it means is that if the underlying stock goes up by $1, your call option price will go, you have to say up or down.
Can you repeat it again? I spaced out, sorry.
This is, if you say, when I asked you interpret delta for me, and all of you did very well, that is, if the delta is 0.5, and then the stock goes up by $1, what will happen to the call option price? Will it go up or down?
Up.
Up. It will go up, right? By how much?
0.5.
50 cents, right? That's what delta means. Same thing, if stock goes down by $1, option price will go
Down
by
50 cents.
50 cents. Now, let's say with that thing, let's say your delta is 0.5692. Not 5, but 0.5692. Now, you bought 569 shares. How can you protect this stock? So you say you are going to sell call option that covers this 569 shares. Okay? So that way, what will happen is when the stock price goes down, call option price will go yes, down. And since you sold a call, is it for you good for you or bad for you?
Bad.
Okay, when you buy a call, anything that call option goes up is good for you when you buy a call, right?
Mm-hmm.
When you sell a call, when the call
Oh,
option
if
price,
it went down, it'd be good.
yeah, going down would be good. So when you're losing on the stock side, you are gaining on the
Option side.
option side. So you are hedged. You call this delta hedge. Based on the delta, you sold the call. Okay? So on your exam, I will just ask about the concept of delta hedging, maybe as a part of another question. You just have to be clear what delta hedging is. That is, if stock goes down, you want to have some benefit from your call, so you sell call. Okay? So that is what I wanted to say about implied volatility in delta hedging. An application of delta hedging is in covered call, very popular. All right, folks, and then whenever you mention any theory, you have to mention the limitation of this theory. And those are the limiting factor that if it is not liquid, Black-Scholes margin will not give you a good answer. If there is a short selling, it will not give you a right answer. If there is an information asymmetry, that means information is not shared all over, a call option price will not come out to be right. And then if you are trying to use this to exotic option, no, it is a plain vanilla option that is Black-Scholes can be applied. So, and performativity and counter performativity, meaning there is, depending on you'd like to see the performance of the call option, Black-Scholes is not the way to go. it can only give you the decision to buy or not buy. All right, folks? Any questions on implied volatility? Any questions on delta hedging?
No, none from me, Professor.
Okay. So what will happen now, I would, you have to give me, because Zoom does not retain the waiting room part of it. You saw the video that I gave you. You need to talk about among yourself. I have already provided inputs for those who, that to improve and resubmit, because I want everybody to have accurate knowledge. So fundamental analysis has to be correct. And in this case, I will just allow one resubmit. So please make sure that it is correct. So discuss among yourself. And I know it is all clear, but when you come back and tell me again, please, that is fundamental analysis is this X, Y is technical, risk management is Z, and mindset is M. Is that clear? I mean, why we are going into breakout room? You discussed the video I played for you. Is that clear, folks?
Yeah.
Okay. So give me some time, please.